Here we are in Desmos, just going to run through some of those examples again. So we started with y equals 1/3 x to the third minus x squared minus 15x. So that was our function, and okay, it's got that cubic sort of shape, well, something like that. And we found the critical numbers to be at x equals 5 and x equals -3. And hey, what did that tell us? Are those really local maxes or mins or what? And yeah, so at 5, you can see that blue line. You know, we can tell from the graph, yes, this is a local min happening at 5. And yeah, I don't know what that y value is. I mean, it wouldn't be too hard for us to figure out if we were to plug 5 back into the original function. But yes, at 5, there is a local min. And at 3, there was a local max. And so there it is. Oh, excuse me, -3, 27. Now, of course, just find the critical numbers. We had no idea about max or min, but we're going to get there. Okay. Then we moved on and we did g of x. I'll just keep it as y equals x to the 2/3 x plus 3 squared. Oh, wow. Okay, so it's got this funky kind of shape. It kind of looks like, you know, from looking far away, it almost looks like just like a quadratic, like a parabola, but when you zoom in, it's doing something. Oh, never mind. That doesn't have a parabolic shape. I take that back. When you zoom in, what's happening? So it's got this nice smoothness for a moment, but then it's almost like it bounces. And it goes up really high, but it's like it's shooting out and up, and it's just going to keep going up and up, bending back this way. So not like a parabola at all. Okay, so it's got that cusp, right? So we found the critical numbers. Got them on my page here. We found them to be at x equals -3. Okay, that's where that minimum happens, and its y value is 0. X equals -3/4. That's that maximum. And at x equals 0, and well, we can see that. We don't need that one. Yeah, right there at the origin. There's a cusp happening there, and that's, well, it makes sense. That's where the derivative did not exist. So all of these are maxes and mins: local min, local max, local min. There you go. And finally, the example we did with absolute maxes and mins. We were looking at x to the 4th minus 2x squared plus 7. I gotta zoom out. There it is. I got this W kind of a shape. Shifted up 7. Okay. And yep, we found, let's see, what, oh, the domain. Let's look at the domain. So we can draw these two vertical lines at x equals -2 and at x equals 3. And I need to zoom back out again. Okay, so there's -2, there's 3. And we'd have to zoom out a long way before we got to where the 3 passes. So I think I'm going to zoom back in. We got, between those two vertical lines, what we got the absolute min to be 6, and yeah, it occurs there at -1 and at +1, the absolute min. The absolute max was up here at 70. Like, oh, I'm scrolling. I'm almost there. Finally, that's where the blue line passes through at 370. Okay. We also found some other criticals. There was one more critical number there at 0. And there happens to be a local max. But because the 70 was far bigger, that ended up being the absolute. But we do have local maxes and a local min, or excuse, local mins and a local max occurring there. Also at -2. Where was it at -2? It was up at 15, and yeah, we computed that number as well. Then we went on to say, hey, what if we change the domain to 0 to 3? So we bring that in a little bit, right? You're like, yeah, well, we still have that local min here at 6 and the local max at 70, but now this critical number we can ignore because we only care about from here to here. Okay, awesome. Hey, good luck in homework. Take advantage. That didn't sound right. Don't take advantage of Desmos. But after you arrive at answers, hey, you know, go for it. Graph something after you found the answers and confirm that you did it right. Or if you're really stuck, you know, go ahead and graph it and, you know, just kind of check yourself as you're moving through a problem. Are you on the right track? That sort of thing. Certainly we cannot answer any of these questions with graphs. We have to answer them with calculus. That's the whole idea. But hey, you know, why not confirm your answer? You know, and it helps you with the concept too. Like, kind of like, oh, that's what we were doing. That's why that step mattered. And okay, that's all I have to say.